Hey guys, just checking sound. All right. I think we're good, aren't we? All right. Cool, we're good. Just give me 1 second. I've just got to go. Just give some. Let's say we're gonna start at 8:04 or no 8:03. Give me a second. I'll be back. You okay? Yeah. All right. All right, guys. So, sorry, come back at the moment. Sorry, Andrew. Do you remember any questions? Otherwise, I was actually thinking about doing one of the papers from 20. I don't know, like maybe. Do we have a theme? Do you want to do some merit questions, achieved questions? There's like two of you guys that have come in and said that today, Crozer. Like, it's just the mark at the moment. It's all right. Like, I mean, if you guys remember any questions, just flick. What do you call it? Flick it to my email, and then I can kind of have a look at this. Well, that's a big one, Sophie. There's like so many concepts. Again, Afif. Now you guys can pick which one it is that we want to do today. I mean, like if we want to do some merit questions, we can. Otherwise, we can do achieved questions, excellence questions. Doesn't really matter. No physics from me, man. Dominic, yeah, pretty much. I think basically a mock exam. I mean, it depends, right? Some people have like a topic test, and then they actually have like a what do you call it? And then they have like a during a practice exam as well. And some schools have like a couple of them, so they can actually get two different variations rather than just one variation. But yeah, generally speaking, that when you get a drive grade, that basically means that if you're sick on your actual exam date, they give you that particular grade. All right, we can actually do merit or excellence questions. I'll actually pick a paper and we'll go through the merit questions from that year. I mean, I don't have time to write new questions at the moment, but definitely I can open up some of the older. Oh, what? Wait, have they actually done? Oh, come on. They've actually removed the old papers. What? Serious? Sorry guys, I'm just having a look at the older papers. Can I access one of them at least? Oh, you gotta be kidding me. Wow, okay, I can't actually access any of the old papers. That bloody sucks. So what's the latest I could actually access? Would that mean all of the papers? Oh, that would stink. That would be so bad. looks like it. Yep. Oh, that is just... What? Why? Why did they remove them? No, have you got a link there that's actually working? Because like I'm looking at the differentiation one, like let me just show you guys. So I'm here in the differentiation standard, but when I go to 2021, it's 2021 is there. 2020 is there, but 2019 is gone. So basically they've removed anything before 2019. No, this is I was looking at level 3 calculus. Oh man, that means I gotta go and rewrite questions all over from the beginning. Okay. That's fine. We'll just work at what do we have? 2019. We'll try and do a couple of questions from there. I'll try and write up the question. No, sorry, 2020. This is the annoying thing. It's like now we need to actually try and work out the answers as well. Mats Margot, I would love a link if you could flick it over to me, to my email, just because then we actually have something to work from. Otherwise it's just a bit stink. I was kind of rushed through. I didn't actually realize that happened. Alright, anyway, look, what I'll do is I will put up a couple of questions. So I think the request was for merit question here, so I'll try and write it up as we go. Insert. Okay guys, so here's our first question for the night. I'm gonna make it a bit bigger. Hopefully you guys can see it. So that's gonna be our first merit question. So we'll try and do about 6 merit questions today, and then we'll call it. So this is my first merit question, and as usual I'll give you guys like a couple of minutes to just try and do it by yourself, and then I'll go through the answer. I need to find the solutions for this, just so that I am on the right track. Open link on a new tab. 2020 assessment schedule 2020. So I was wondering what this level, like a couple of the level 1 kids were talking about it yesterday. Sorry Afif, yeah, it's level 1 is tomorrow. We're doing like merit questions today from differentiation paper. So as I said, I'll give you guys a couple of minutes. So what is the time? 8:09. So I'll probably go through the answer at 8:10. 8:10. 8:10. I will try that. NCA differentiation level 3 2015 paper. Who has it hidden? It's broken. that sucks. That really sucks. All the links are actually hidden. Now I tried that, Crozer. That didn't actually work. I did try it. Nah, man, these are old glasses. I've like my eyes. I've got an issue. I need to go get it checked up with the doctor soon. So, by the way, I didn't realize the time going as well. I've kind of rearranged my configuration. Give me a second. I'm just going to rearrange it back, because then I can actually keep track of the time and then get through with these questions. All right, let's go through question 1 here. Much appreciated for that, Jackson. I'll probably have to take some time this weekend to kind of work through it and sort it out. All right, so with this question, guys, understanding that we have actually got a quotient rule that you have to do. All right, so if you have y is equal to, I'm going to use u v here. If you do forget the quotient rule, remember that it is in the formula sheet. So y dash, which is going to be u dash v minus uv dash divided by v squared. So what I'm going to do is I'm going to put down u is equal to 3x, which means u dash is equal to 3, and then v is equal to 1 minus ln of x. V dash is equal to, what are we going to get? 1 minus ln of x. So 1 minus 1 over x. No, it's not going to be 1. Negative 1 over x. X ln of x. 1 minus x. Yep. That's all good. And then we're going to have to try and put through it. Put it together, sorry, and put through it. So u dash is 3. V is equal to 1 minus ln of x. And then what we've got here is minus u, which happens to be 3x. I have a feeling I might have actually stuffed this question up. What have I done here? Oh no, maybe not. 3x times negative 1 over x. All of that is over v squared, which is 1 minus ln of x squared. Now, this part right here is worth achieved because what we've actually done is we've just differentiated it using quotient rule. Now, if we want to find out that it has a stationary point, remember that y dash is equal to 0 to find the stationary point. So we're going to put 0 is equal to 3, 1 minus ln of x minus, well, it's going to become plus. It's just going to become plus 3, really, because you've actually got x cancels out with the x in the denominator, and then negative 3 times negative 1 is equal to plus 3. Now all of that is divided by 1 minus ln of x squared. Now because this is all equal to 0, we can actually say that the numerator must equal to 0. So we can actually say 0 is equal to 3, 1 minus ln of x. I hope this works out, because I have a feeling I might have actually done something wrong with this question. We're going to rearrange this, so we're going to get negative 3 equals 3, 1 minus ln of x. Now I'm going to get rid of the other 3, which means we're going to be negative 3 over 3 is 1 minus ln of x. We've got negative 1 is equal to 1 minus ln of x. Rearranging this, we're going to get ln of x is equal to 1 plus 1. Ln of x is equal to 2. So x is equal to e to the power of 2. Whatever that is. But we don't really need to worry about it. We can just leave it as just e to the power of 2. Now, what I'll do is I'll put down some line numbers. And if there is any particular line that you guys have a question with, feel free to ask, and then I'll try and work it through with you guys. Yeah, Ali, this was the first question. We kind of were kind of fishing around for the old exam papers, and we just couldn't find it. So we kind of modifying the question. I'm modifying the questions as we go through these. But yeah, if you have any questions, ask away. Otherwise, I'll just start working, typing up the next question, which is, let's do y equals x squared. Find the equation. Insert equation x equals pi pi pi. Where is it? Thought I've seen pi here somewhere. There we go. Sorry guys, just writing up the next question and then I'll come back and answer all the other questions that if you do have any. How does it go from 1 to 2? 1 to 2 is because when you have a denominator, and if I bring the denominator to the other side of the equation, you have 0. So 0 times the denominator, well, it just becomes 0. So we don't really, like, if you have like a fraction that equals to 0, then we completely ignore the denominator of the fraction and we just have to say that the numerator is equal to 0. So, okay, is that all the questions, or is there any other questions that we have? Okay, I'll assume that we're good to go with that. So the next question is this one here. It's another merit question, and yeah, I'll give you guys like 2 to 3 minutes to do this. So right now it's 8:18, so we'll probably go through it at 8:20. My email is going off. Why is my email going off? So guys, with this one again, like when you differentiate it, you should be able to get that achieved. And then when you find the equation of the tangent when x equals to pi, that's the merit part of it. Be careful with this type of equation because sometimes I see people doing, they forget to do product rule. So just kind of give you that little hint right there. When you have like two functions that are getting multiplied with each other, like this, in this case, you've actually got to use the product rule. So keep that in mind as you work through it. I would actually work with radians because they've given x as pi. That's a good indication that you probably should be working in radians. But the other thing also is that with this type of question, you can actually try and I think you can actually just leave it in terms of pi as well. What's the time? I've got 1 more minute to do this. function, insert equation. So we've got f of x equals just writing the next question, guys, and then I'll go through this one here. Hey Talia, welcome. Okay, so let's actually go through this question. I think it's well past 8:20 there. Sorry guys, just trying to do a couple of things here. So we've got u is equal to x squared, and then v is equal to sine x. If that's the case, we can say that u dash is equal to 2x and v dash is equal to cos x. Now we are trying to find equation of the tangent when x equals to pi. So when you want to find equation of a tangent, you're going to need x, you're going to need y, and you're also going to need f dash of x. F dash of x is the gradient when x equals to, well, whatever the gradient at x equals to pi. So in this case, there's quite a few components to it, and you might be thinking, oh, this is just a merit question, why is there so much working? The reality is, yeah, there is quite a bit of working. So the first thing I'm going to do is I need to actually figure out what the y value is when x equals to pi. So when x equals to pi, y is equal to pi squared sine of pi. Sine of pi is, what is it? I think sine of pi is 0 if I'm correct, but let's just check that on the calculator. Good idea to just check that your calculator is in degrees mode. Because what is it, shift setup, there we go, not degrees, radians mode, right, because we're actually working with pi. So we're going to make sure we put that in radians. Once we do that, we can actually click on sine of pi, which is somewhere there, and as you can see, that's 0. So when x equals to pi, y is equal to 0. All right, so that's just something to keep in mind. So we've got our point, which is pi and 0. The next thing we need is the gradient function. So when x equals to pi, right? So we need to differentiate this. So we're going to differentiate this by doing product rule. So it's u dash v plus uv dash. And when we do this, we're going to get 2x sine x plus u, which happens to be x squared, v dash, which happens to be cos x. All right, and once again, we're going to put f dash of pi, because that's what the gradient function is. We're going to get 2 times pi sine of pi plus pi squared cos of pi. Now we've already figured out what sine of pi is. Sine of pi is equal to 0. So then we can actually work out what cos of pi is. That's going to be -1. So in this entire case, we're going to get plus pi squared times -1. So what we've got here is the gradient for f dash of, or the gradient at pi, which is f dash of pi, equals to -pi squared. So now, if you think about it like this, this is the m part, this is the x and y part. Now we need to come up with the equation of the tangent, which is y minus y1 equals m times x minus x1. Now if you guys want to do the y equals mx plus c method, you could also do that, and then work out what c is and rearrange it. But you could also do this one here, and I'm going to do x1 and y1 here. So when we do that, we're going to get y minus 0 equals -pi squared, and then x minus pi. And what we're going to end up with is y equals to -pi x squared plus pi cubed as our final answer. And so that's going to be a merit right there, and you're probably looking at achieved there and merit there. And once again, what I'll do is I'll just throw up a few line numbers. So if people have any questions, they can just yell out the line number and then go from there. Now it is super useful for knowing like sine pi and cos pi, because it just makes things a little bit easier when it comes to doing these types of questions, all right? Because they generally tend to give you questions which kind of work out nice. Yep, Zoe, that's actually fine if you want to use pi squared as a decimal. But that's one good thing about calculus, is that they tend to, like, a lot of their answers tend to come out to be nice, like square numbers, or like easy numbers to actually manipulate. Mahali and Charlie, good luck for your mock exam tomorrow. There you go. Nah, ADAC, these are old glasses. It's just I've had an issue with my eye, and just wearing my contacts is painful, and I think last night it really got quite bad, and then yeah, so now I just gotta wear glasses for a couple of days and then go get it fixed up on Friday. Yeah, you're right. You were right. Well, I don't know about the evil, the other part of it. But yeah, like I think I've got a few folks that I might have got it somewhere, and see if I can try and get it. But that's a bit stink that they decided to do that. Any other questions, guys, with this? If you don't, we've got another merit question that I can move on to. ADAC, yeah, like I was like, I think I probably won't stop till exams finish at this point. So there'll probably be like 5 a week leading up to the exams. Just mixing it up. Because I think it's just the MCAT is over next week, and then after that, it's just I'm just gonna keep going through some of these questions. Hey, VDuck. All right, so I am assuming we could probably go. Nah, it's all good, ADAC. Okay, let's go to the next question. Yeah, we'll probably do integration next. I think I did complex numbers last week. I did do that integration paper, which I still haven't actually fully edited yet, which I need to. I keep forgetting. Sorry about that. So here we go. Here's our next question. Another merit question as usual, and see how you folks go with it. Oh, this is an annoying question. Oh. Yeah, right. It's interesting because at level 2 and level 3, you don't really get the spam like we did yesterday for level 1. It's just I think by this time people kind of just go, well, I just want to learn my stuff and get over with. Um, yeah, well, I mean, I don't know how you'd put that, right? Because it's more like, people come, people watch, whatnot. Don't really pay attention to it too much. Just kind of do a few problems and then go through this. Hi, Stacy. Um, Let me know, guys, if you want me to go through the answer for this, or if you need a bit more time. I kind of been a little bit distracted. Like, I think it's different, right? When I wear glasses, it's like my eyes are just like messed up. Like, I kid you not. Like, if I remove my glasses, I can't even see my own face on the screen. It's like that. That's how bad my eyesight is. We're doing differentiation merit questions, Stacy. That's what we're trying to do. We're trying to do like parallel questions from merit differentiation. Sure, Gaiden, go give. Well, if you're in his class, do say hello to him, because, well, actually, I might have visited you. Were you there actually when I visited his class? Not today, Kevin. Not today, but we will definitely be doing. Just get started with the merit questions, and then after that we might do one excellence question. I'll see, because writing these questions as I'm doing the tutorial is actually quite hard. It's pretty crazy to try and think of writing excellence questions while that happens. I can't even write one. Maybe one of them I can do. Actually, no, we can do one excellence questions after this, because the other merit questions doesn't seem to kind of work out. Okay, so let's do this one here. So what we've got is find the x coordinates of any stationary point. So we've got to differentiate, put it equal to 0, and we're pretty much good to go. Once again, what we have is we have got a product rule here, and so we're going to kind of put down f. What is it? We're going to put u and v. So u is equal to 2x plus 5, u dash is equal to 2, v is equal to ex squared minus k. So v dash is equal to 2x e of x squared minus k. Just want to check that we're on the right track. Yep, that's all good to go. So then we're going to write down f dash of x is equal to u dash v plus u v dash. Now u dash is 2 e of x squared minus k plus u, which happens to be 2x plus 5, and v dash happens to be 2 times 2x e of x squared minus k. Okay, now this is pretty much our correct derivative for this, right? And so we're going to get like an achieved grade for this right now. But how do we get this to be a merit? So for merit, we need to actually put down, we need to figure out what the stationary points are. So we're going to say f dash of x is equal to 0 for stationary points. So we're going to get 0 is equal to 2 e of x squared minus k plus 2x plus 5 times 2x times e of x squared minus k. All right, now what I want to do is I'm going to look for common factors. Now common factors is that I've actually got 2 e of x squared minus k as common factors for each of those things. So I could actually take it out, and I'm going to get 2e x squared minus k multiplied by 1 plus 2x plus 5 times x. And I really hope this is going to work out, but I have a weird feeling that this might not actually work out, partially because I might have done something stupid by writing the wrong question. But anyway, let's just see what happens. So at this point, we've actually got two brackets that actually equal to 0. I think I might have actually done this one wrong. Did I copy it wrong? Plus 5 is not going to work out. 2x squared plus 5x plus 1 doesn't have any solutions. 2x squared minus k does not have any solutions as well. Okay, well that's fine. We'll just work with the question with what we have. So in this case, we've actually got two brackets that equals to 0. So we've got 2e to the power of x squared minus k equals to 0, or 1 plus 2x plus 5 times x is equal to 0. Now I'm just going to expand the brackets here, and I'm going to get 2x squared plus 5x equals to 0. 2x squared plus 5x plus 1 is equal to 0. Now, as I said to you guys before, I kind of just worked made up the question on the spot, and sometimes this always happens, but it's okay, right? I mean, like, I should have actually said at the end, if any, because unfortunately for this question, what happens is that we can't actually find any x values where there's going to be kind of any stationary points at all, which is really weird. But it's like, yeah, there's at no point is there a graph. This graph is going to actually have a stationary point, and I'll show you guys why, all right, as well, because so if we go and have a look at the actual graph itself, I think my original graph was 2x plus 5, and I did e to the power of x squared minus k. Oh, I forgot the 5. Why is it not working? Two x plus 5. Something's not right. But if it's k, it should work. Have I made a mistake somewhere, guys? Trying to see where I made the mistake. Two x 2 times ex squared minus k, that's all correct, plus 2x plus 5, 2x ek squared, that's correct as well. Let me just check this. Everything looks right. Okay, I must have made a mistake somewhere. I just can't figure out where it is. See, this is what happens when I try to make up questions on the spot, man. Like, I need to run the questions, check the questions every time to see if it actually works or not. I can't actually see anything that's wrong here. Because when I do that, I get that 2x is fine, 2x times that's also works fine. Taking the common factor out, which is the 1, that's looking good. That's all fine as well. Yeah, I'm actually not sure, guys. I think I just probably wrote the question wrong, but I mean, ideally what it should have happened is that in this final step here, we should have actually got a quadratic that we can actually solve. And then once we solve that quadratic, we would actually get two solutions. So I guess I must have messed it up. But then the reason why I say I messed it up is because when we do this, I just want to double check if that's actually e right there. E exponential functions. Can I see e there? Unless it's the wrong one. Nah, it should be correct. That's fine. 2x plus 5 times that. It's looking all good. So, I mean, I can see that there's actually 2 turning points here. If you guys can see, there is that. Unless, what if I do it in the calculator? I just want to have a look. Let me just check something here. Unless I made a mistake here somewhere again. Can you actually factorize 2x squared plus 5x plus 1? Let's go check it out. Maybe I made a mistake. Polynomial, 2x squared. Oh god, I'm an idiot. 251 actually can be factorized, can't it? Oh, I'm such an idiot. There we go. I did have the right question. No, because look, it does factorize, because when we factorize the values, they're real values. I don't know why, I just had a brain kind of freeze there. So I've got these two solutions. X is equal to negative 2.19 and x equals to minus 2.28. Oh my god, there's my two answers. Minus 5. You got minus 5? Really? I've got 251. I don't know, because we can factorize it, right? Like 251. Well, why did this one give this? Oh man, I'm making so many mistakes today. 251. That looks right. How did you get that z is equal to minus 5? And why is this one giving us a different answer? Square root of... Now, Sophie, you will get two separate equations, but let me just do this the old-fashioned way, because I'm getting frustrated with this question at the moment. There's no numbers that'll multiply to 2 and then add up to 5. So no, it has to be these ones. Now I think definitely, what's it, Sophie, Zoe, I think this is what you should get. Minus 5, I think minus 5 plus or minus square root of 17 divided by 4. Yeah, that's fine. I think that should be okay, because if we do that, so square root of 17 equals to that, minus 5 equals to that, divided by 4 equals to that, which is what I've got as my first answer, which is negative 0.219. So Zoe, that's actually a correct answer, so you're actually on the right track there with that. Right, so I did do the right question, but I just didn't do the final step, which was my bad. Sorry guys. Our last question, which is going to be an excellence one, and I'm going to actually pick one that has actually worked, so that we're not kind of wasting time. Let's do this question here, which is actually one of my favorite kind of questions, these ones. Where is it? 24. There we go. Okay, so we're going to do the last question, which is going to be an excellence one. By the way, no, we're not doing integration. We're just focusing on what do you call it, differentiation, and I just bombed a big question. But anyway, did you guys have any kind of questions with that? I mean, I know I kind of messed around with it a bit, but I think I should have just factorized. I don't know, in my head I just saw the question, and I was like thinking level 1, because in level 1 you couldn't have solved it, and you know, it's just that's the problem. I've been doing too much level 1. Yes, Hex, yeah, we will be doing another one later on. Alright, so the only thing I'm going to change here, guys, actually no, we'll actually do this question here. This is actually one of my favorite excellence questions, because you can actually, it does work out very nicely every now and then. It's a bit annoying to start with this question, but that's pretty much all the information you get given, and then you've got to try and work out what the maximum volume is. Now I've been doing too much quadratics with level 1, so when I saw that 2x squared plus 5x plus 1 in my head, I straight away went, oh, I can't actually solve this because it's got to factorize nicely. And then I completely forgot that actually doing level 3 calculus, which means I can just differentiate, use the calculator and be done and dusted. Hello Rice, welcome along. So with this question, guys, just the only kind of clue that I'm going to give you guys here, which is already kind of mentioned there, is the sphere has a radius of 20. Also, I think you guys need to know the volume of cylinder, which will be given to you guys in the exam, but pi squared h is volume of cylinder. And that's pretty much all the information you would actually need to know. Sorry, Hex, yeah, just put that up there. That volume of cylinder formula would be given to you guys, which is pi r squared h. Now, if you're kind of struggling to kind of start this question and go, geez, I got no idea where to go with this question. So there was a reason why I did that that diagram with the 20, because remember that with pi r squared for h for the cylinder, your radius is actually from here to here. That's where your radius is, from there to there. And then your height of the cylinder is actually from there to there, which means half of your height is from there to there. I hope you guys can actually see that with that color, because otherwise I might just change it to a different color so you guys can actually see it. So that is pretty much all the hints that I'm gonna have to give you for this question, and you should be able to kind of see if you can try and work through some of these things. What's the time? I'm gonna give you guys maybe about 3 to 4 minutes for this, just to kind of do it. So remember guys, when you differentiate volume function, you've actually got two variables there, which is r and h. Ideally, you want to have it written in one variable. So you got to figure out a way to get rid of one of those variables. And that's why I have that triangle inside the cylinder as a diagram. So you can actually use that triangle to try and figure out how to eliminate one of the letters. All right, guys, would you guys like a little bit more time, or do you guys want me to actually go through this question now? Let me know. That wasn't the question, but I wanted to know if I can actually go through the answer. But thank you anyway, Lucy. All right, so I'm going to assume that we want to go through the answer because I think I'm crashing very slowly today. So what we're going to do is most of these questions, right? Like most of these questions, they end up with like either similar triangles, Pythagoras, one of those combinations. So in this case, what we've got to do is we've got to differentiate the volume function, put it equal to 0, and solve it. And then we get the radius and then substitute it to find the maximum volume. Now the issue is, as I said to you guys before, we've actually got R and we've actually got H as well. So we've got to figure out a way to get rid of one of them. And that's why we are going to end up using this right angle triangle right there. Because this right angle triangle, it looks like this, H over 2, R, and 20. And what we can then do is we can actually say R squared, because we know that A squared plus B squared is equal to H squared, which is the basic Pythagoras hypotenuse. So we've got R squared plus H over 2 squared. I probably should have used a different H, right? But it doesn't matter, you guys get the idea. That's hypotenuse, which is 20 squared. So we can actually say that R squared is equal to 20 squared, which is 400, minus H squared is H squared, 2 squared is 4. So what I've actually done here is I've actually written a R squared in terms of H squared. So I'm going to go back to my volume equation, and instead of writing it with R squared, I'm actually going to write it with 400 minus H squared over 4 over H, because that's what that R squared is equal to, the 400 minus H squared over 4. Now once I do that, I'm going to expand this brackets, which means I'm going to get 400 pi H minus pi H cube over 4. This is my volume function, and because this is my volume function, what I could do is I could actually differentiate it. So when I differentiate this, I end up with 400 pi minus 3 pi H squared over 4. Now pi is a common factor, so I can take it out, and I'm going to end up with 400 minus 3H squared over 4. Now I do know that the volume, when I differentiate the volume and put it equal to 0, it's going to give me what's that minimum height or maximum height that it can be, and so on. So I'm going to put V dash is equal to 0. So I'm going to get 0 is equal to pi multiplied by 400 minus 3H squared over 4. Next step is 0 divided by pi. Well, that just becomes 0. So I've got 0 is equal to 400 minus 3H squared over 4. Rearranging this, I'm going to go here. I'm going to get 3H squared over 4 is equal to 400. 3H squared is equal to 400 times 4. And then H squared is equal to 1600 divided by 3. H is equal to square root of 1600 divided by 3. We can say H is equal to 40 over root 3. Now I've not actually calculated the maximum volume yet, because the maximum volume, I still need to figure it out. This H is when the maximum volume actually happens. So because of that, what I'm actually going to do is I'm going to go back to my volume equation, and I've got pi 400 minus H squared over 4 multiplied by H. So when I do this, I'm going to get pi 400 minus 40 squared over 3 times 4 times 40 over root 3. All right, and if I put this in the calculator, I mean, you don't even need to do that. You could have just done it straight away in the calculator. I would have just gone volume is equal to pi, so that's actually a quick way to do this, by the way. This is a neat little hack. What you could do is you could actually go 40 divided by square root of 3. All right, so that's that 23.09. That's the height, and I'm going to leave that as answer. But then what I'm going to do is I'm going to go shift pi multiplied by what was it, 400 minus h squared, but h is actually the answer, so I'm just going to go answer squared divided by 4 close bracket multiplied by h again, which is the answer, and I'm going to get, I've messed it up somewhere. Hang on, let me just try and have a look at this. 100, I put 100 instead of 400. Oh, that's silly. Unfortunately, I can't do the repeat of this because it's got a different answer. So what you could do though, you could actually go 40 divided by square root of 3. Yeah, shift square root of 3, and I could store this as alpha h. Where is it? Alpha h. There it is. So basically what I've done is I've actually put the letter h as this value. So anytime I press h, I'm going to get that 23.09. So now when I do this whole thing again, I'm going to do shift pi multiplied by 400 minus alpha h, which is my height, squared, divided by 4, and then multiplied by alpha h. And when I do that, I actually get a volume of 19,347 centimeter cubed. And that's pretty much it for excellence. Yeah, thanks Hex Rice, because I missed the stat, the chat, and then I kind of just went about doing that. But anyway, look, I mean, I hope I showed you guys another little trick with your calculator where you can actually store a particular letter with a number. It's probably a lot harder to get rid of the height variable, right? Like, I'll wait for this stupid plane to get past our house. So if I, jeez, that's a huge plane. Is it finally gone? Thank you very much. What did I miss? Could you rearrange for in terms of h? Now, like the reason why I chose r squared and not h in terms of r, is because if I chose h in terms of r, this is what I was looking at. H squared over 4 is equal to 400 minus r squared, and then h squared is equal to 1600 minus 4r squared, and then h is equal to square root of 1600 minus 4r squared. So h is equal to 1600 minus 4r squared to the power of half. Now, if I was to substitute v equals to pi r squared h, then what's going to happen is I'm going to end up with this monstrosity of a product rule, because you've actually got two products here. One is pi r squared, and the other one is this other big thing here, and you've got to use product rule to kind of differentiate it, and you're going to end up with this super ugly, massive, big equation. So, and that's why we kind of have to be careful about which letter you want to eliminate. Now, a good tip is this: when you saw that r squared and you've got r squared in the Pythagoras, you should straight away go, right, I want to get rid of the r squared, because that's a lot more easier to work with compared to working with square root and product rules and so on. 9 o'clock on the dot. There we go, guys. Look, that's an excellent question there, and that's pretty much us for today. When are you doing complex numbers? I think we're going to do integration next, backpole. So can't you simplify it to 40 minus 2r equals h? No, we can't do that, Kevin, because it's when you square root, remember, like it doesn't actually work like that. It does work if it's just 1600 times 4r squared, but it doesn't work with plus or minus. Hey, good luck for it, Rise. Would love to see some questions just to see what you guys are getting and how we can actually rewrite those questions. The doctor, I think like I don't know the physics codes, so I wish I could help you, but I don't know. I think it's Weebly, Mr. Weebly that does physics. Oh, sorry. Oh my God, I'm so blind. Like seriously, this is what happens when I'm wearing my glasses. It's like I'm starting to see things differently. You were asking about level 3 playlist. Oh man, that's terrible. Hang on, let me just show you where they are. Shows how tired I am. So if you go into the main page, ooh, live, okay, yeah, that's us. But if you go right down, level 3 calculus exams and revisions, all the past exam papers are there, all the tutorials are there, and I think if you go further down, there's some good some of my old revision stuff that I used to do with my classes there as well. All right, I read that as physics. That's just terrible. Arav, what I'll do is on Sunday night I'll post a link, but it'll most likely be either Tuesday or Wednesday next week. I'm probably thinking Tuesday, and then after that, following that, after that you can actually kind of we'll probably do a bit more. I never know, Hex, not Hex. What is it? Rice. You asked me that question. I never know what happens with that. Let me just see. Can I do an inception here? So if I go into that, whoa, that is like messy. That is super messy. Okay, no, I'm not gonna do that. I don't even know where everything is. I gotta go to main recording. God, that was just crazy. I think it's because I'm streaming and then watching the stream of the stream, therefore it just kind of creates a loop. I was just wondering when the next MCAT live. Ponniha, I think we're back tomorrow, Ponniha, for level 1. There you go, Rice. I think we've just solved that problem. Kevin, it's Mr. Walden Scholar. Like look his stuff up. I think I have it here somewhere. Oh God, I'm like watching my own things. Mr. Walden Bowman, where is it? I thought he did it. I don't know where he put it. Mr. Weebly, Huntley, Walden. Calculus, maybe. What did he call it? Michael, come on, man. What did you call the channel? I don't know where he put it, man. Like scholarship calculus. Scholarship. Come on, Michael, where'd you hide it? Alright, I can't actually find it at the moment, guys. What I'll do is I'll see if I can try and get him to send me a message, and then I'll see if I can put that up there, Hex. Zoe Mayal, a lot of the live tutorials that I did, I think they were all like exam papers. It's very hard to find, like, I mean, as you saw today, I struggled to create questions because it takes like a good 15-20 minutes to write questions and then kind of get them to work. So apart from that, apart from some of the questions I wrote, I don't really have much here. Arav, unfortunately Sunday and Monday is going to be predominantly focused on the MCAT because their MCAT is on the Tuesday. Now there's always copyright issues as well, Hex. Like copyright issues is the major pain, because it's like, you know, if I do questions, I mean, like, look, if you guys find questions, you can send me some screenshots, and then like I'm happy to kind of work through it. I'm not sure, Kevin. It might be. Yeah, Prabhu, you can send it to me on my email. I think it's in the description. Just send it through there and then see if we can do it. Rice, when do I do the exam? I don't think it matters at level 3 this much. It's not as strict as physics, I believe. Well, the one that I found fairly useful was D&D books, but I think they too have started to kind of like repeat the questions. Sushami, because it was 40, where was it? Where did I do that? 40 squared. Oh, how did I do 40 squared over 3? Because, Sushami, it was, h was 40 root 3. Because h, it would help if I use a right pen. Because h is actually 40 over root 3, h squared is equal to 40 over root 3 squared, which is equal to 40 squared over 3. So that's what happens with that, Sushami. No, guys, look, if you are going to send me questions, can you please send it to me on my email? Because sometimes with Instagram, what happens is that the quality of the picture is really low. And so by the time I kind of zoom in, I can't even read any questions. So if you can email it to me, we can actually work the next time. Prabhu, I know that like with complex numbers, there's a playlist that I did a couple of years back. It's called like the Mathematic Level 3 playlist, which is hidden somewhere in my channel. If you look it up, you'll find it. But there's basically like 12 or 13 videos in it. They're like full extension, like fully covers complex numbers. And I know guys that have actually watched that. They've pretty much got like around that 18 and above for complex numbers. Now, unfortunately, I've not done that for differentiation or integration, partially because I don't know, I've just kind of never really sat down and worked through it. Sometimes I think maybe I should just do like one of those nights where we do like a marathon of just like the whole topic for like a good 3-hour marathon or something like that. I think about it and then I just get, I don't think it's something you guys would be interested, so I'm like, I never really kind of got around to it. Well, like a massive 3-hour differentiation thing during the holidays. He's serious. Come on, man. Like people would get so tired, Zoe. Like the entire topic of differentiation, like this big marathon. Yeah, like in the holidays, like I was thinking like maybe pick a half a day and just go, let's just kind of power through this, like what we did, because usually what I do is like I will actually do I used to do like exam questions and the differentiation, so it's like yeah, no, look, I think someone sent me the exam papers. Let's see if we can actually make it happen this holidays, because I've got a fairly packed schedule, but even if it's like in the evening for a few hours, if we start like say 7 o'clock and then go till 10 o'clock for a couple of those nights, we might actually get through both differentiation and integration, and I'll actually have like 9 hours worth of footage for people. Now we do the whole thing, Zoe. We just go through the whole thing, because the way I used to do it is like I used to start off with all the basic skills. I cover all of them, and then after 6 hours of that, and then the last 3 hours, we basically just grind through excellence questions, because trust me, by that time you find like the achieved and merits like too easy. Nah, Hex, it's not hard at all. I always forget it, but it's a pretty easy ouch, that's gotta suck, GL. But don't like kind of feel bad about it, because it's like the questions they give us quite horrible. Yeah, like Zoe said, I mean, once you get the Newton's law of cooling with the right equation, you're pretty much sweet to go. It's like the exponential, not exponential, differential equations in integration is one of the most easiest things, and I don't know why people complicate it, but it's like, you know, you swap the y to one side, swap the x to the other side, and you pretty much kind of integrate it, and then you're pretty much done and dusted. As for your thing, Raid, unfortunately, I'm actually can't get LASIK. I can't get LASIK. It's I can't get LASIK because I've got serious eye problems, and I think my power is too. My eyes are too weak, so LASIK won't actually help out. Connor, we are doing another one tomorrow. Benjamin, at level 3 calculus, it's like a minor error is like, usually it depends on the question. Like for some questions, for certain bit of, like, yeah, like, you know, you've got the answer in context, or like you missed like something small, then you can still get E7 for it. And now they're doing a lot of E7, E8 questions, like where if you have like a minor error, like, you know, you forget, like in this question, say for example, you work out the height. I'm just trying to think of what would categorize as an E7 for this question. Like, let me just check. So for this question, an E7, well, it's not really an E7, but like a minor error. What would you call this a minor error? Let's say you get a numerical error, but you've shown all the correct working for this. This question, then you probably would be looking at getting yeah, probably looking at getting like an E7 for it. So let's say, like, you know, you make a mistake right here, like in this part you make a mistake, and so therefore you get this answer correct, but then you've done all the other work right, then you could potentially get, oh, I just realized I've kind of removed that part. Hang on, let me just show the working. So let's say you make a mistake somewhere here in your calculations, you make a mistake, but all of your working is correct. If that's the case, then you probably will get like a full E8. But if you make like a minor mistake, then you'd get a E7. That's what they mean by. Will you watch the Cricket World Cup? Man, I gotta be honest. The last Cricket World Cup was a bit depressing. Like, I don't think I'm still over. I stopped watching cricket after that was the last cricket match I actually watched, when England beat New Zealand in the final. It just killed me, man. So I stopped watching cricket after that. Good luck, Zeki. It's good fun, Ara. It's good fun to kind of do this stuff. Ramiru, I wish I could. I've applied for it a couple of times, but I think they probably said no, not this guy. Do you follow sports? Yeah, I do, CubeZan. You know, I kind of watch a little bit of football here and now when I get a chance. Yeah, so Benjamin, I think that'll classify as probably an E7. So it's like something like putting in the wrong number at the end. Yeah, you're probably looking at an E7. Oh man, that last football World Cup was pretty impressive, right? I have to say, I loved it. I absolutely loved the whole thing. Rugby World Cup, All Blacks. Here we go again, eh? I am GL Yusuf. Like, it's Wednesdays are usually like my tired days at school, but you know, I think this is doing a little bit of this. I feel good, and then now I can actually go and get a good night's sleep. Anyway, guys, look, keep an eye out on the what do you call it, on the socials. I'll put out when the next next tutorial, like live stream, is going to be, and then we're going to go through integration next time. Thank you for the person that actually sent me those questions. Now, if you guys have any questions, feel free to take some screenshots. If you have the answers, that would be even better, because then we know at least we're not wasting time trying to figure out things. Just send it through, questions and answers. If you have the answers, even if it's just the final answer, then we can kind of work it through and see if we can answer some of these other questions that you guys have. All right, so in saying that, folks, have a good night, and then if there's any level 1s hanging around, I'll see you guys tomorrow. All right, take care, guys. Till the next time, see you later.